Hola, amigos. Welcome to video 8.2. We're going to talk about mole-to-mole conversions here. We're going to be on page 5, so we're going to pick up where we left off with those mole ratios. And now we're going to actually put them in terms of a problem. Okay, so we're going to convert from one substance to another. Guys, this is something we've done already, where we've converted between moles and grams to mole back in Unit 3 when we dealt with the mole. But now we're going to go from one substance to another. So it's very, very, very important that you guys write down everything like I do. And what I mean by that is you've got to put the substance next to your numbers, okay? It's not good enough to just put moles there, because now you're going to have two different substances. You've got to keep track of those. So just putting moles for an answer is not going to be good enough. If you don't put the full unit, you're not going to get credit for it on the Regents exam as well as on any test or quiz that you take with me, okay? So stoichiometry problems, we kind of abbreviate them with a given and an unknown. So you're going to see that in the examples, guys, that I have for you here in the flow chart. Now, one of the best things I've seen students do in the past is that they have memorized this flow chart, and this is something that they write down on a quiz and test so that they can use it to look at. It's a roadmap, just like we had the roadmap back in Unit 3. So I highly recommend doing it. Now, what you will see with the roadmap here, guys, is that we're going to add on to it. So this is kind of the middle part of the roadmap that we will then add a piece over here to the left, and we'll add a piece over here to the right as we go through this unit in these videos. So we're going to kind of start off small with one step and then build from here, okay? So this first type is what we call kind of type 1. These are mole-to-mole problems, okay? Always, always, always make sure you begin with a balanced equation. So let's just jump right in. You'll see that they're similar to problems we've already done, but now it's a new little twist. So we're going to use that previous reaction. Like I said in the last video, the previous reaction, guys, that I'm referring to is from the last page in your notes. It's where we had 2 moles of aluminum oxide breaking down into 4 moles of aluminum plus 3 moles of oxygen. Now, with this roadmap, there's some components here, guys, that we will kind of talk about and how we use those in context of a problem. So let's just jump right in. So how many moles of aluminum can be produced from 13 moles of aluminum oxide? So that's all that you're given here in the problem. You've got to identify what's my given and what's my wanted. That's kind of the big piece you've got to identify first. And if you misinterpret those or kind of read the problem too quickly and you get them wrong, the entire problem is going to be wrong, whether you show all your work or not. So you've got to be slow and make sure you are thorough with understanding it. So my encouragement to you is kind of underline what you're looking for, box what you have already. What you have already would be called your given. Okay, so you're going to see me with every problem that I do here in the notes. I always write down my given and my wanted, and then I start using my roadmap to kind of help guide me through the problem. So my given in this case is 13 moles of aluminum oxide. Now again, if you can't go from names to formulas, guys, you're going to struggle within this unit. This is why naming is so crucial. Okay, so aluminum oxide is aluminum and oxygen. That's this guy right here to the left. That's my reactant. Okay. So I have 13 moles of aluminum oxide that I'm starting with, and I want to know how many moles of aluminum I can get to. So there would be my wanted. Question mark, moles of aluminum. So I know this is an extra 5 to 10 seconds of writing down your pieces, guys, and kind of identifying them. But when you have mixed problems, like you're going to have after video 8.4, okay, where everything's all mixed, all 4 types are mixed together, you've got to be able to identify, well, where am I starting on my roadmap and what am I trying to get to? So this is a very, very vital piece that if you start skipping this, don't be surprised if you're confused and you're lost and this seems harder than it needs to be. But if you use your guide points, like think of these like the North Star, okay, if we're guiding you where you're going, it's going to help you out a whole lot. So here, when I take a look at my given and my wanted, I am going from moles to moles. So this right up here, and you'll see what I mean as we get into more in depth and we start adding the other pieces to our roadmap, you'll see just how important this is by looking at your units. Moles of one substance to moles of another. I know that's going to be a one-step problem because I'm converting substances. Remember, you cannot go from grams of one thing to grams of another because their molar masses are different. We talked about that back in Unit 3. If you don't remember that, we did. So now we're going to start to see that. We got to compare moles. So I'm just going to write down my given. Always start with my given. So I've got 13 moles of aluminum oxide. Okay, and I'm going to set up my T-chart like what I see up there. Remember, always put a 1 below your first fraction as a placeholder. If you start trying to put stuff there, you're going to be completely off and your units aren't going to cancel out. Like I said, way back in Unit 3 and even from the beginning of the year, guys, let your units drive your math. Cancel your units out so that you know that you're in the right spot. What do I mean by that? Well, as a recap, I've got moles of aluminum oxide on the top of my first one. I don't want to end up with moles of aluminum oxide in the end. So, if it's on the top, where does it have to go to cancel out? On the bottom. Moles of aluminum oxide will be on the bottom here. What am I trying to get to? My given is going to go on the top. Moles of aluminum. So, I'm sorry, not my given is going to go on the top. My wanted will go on the top. So take a look here, guys. If I'd color coordinate it, like maybe I should, let me go back and redo this. You don't have to. Okay, my moles of aluminum, that's what I want. That's my wanted piece goes on the top. Now, I always encourage my students, get your units set up before you start worrying about numbers. Okay, the units are never going to lie. Okay, these have to go in this order for them to cancel out. Now, the number that's associated with it comes from our balanced equation. This is why we always have to make sure we have a balanced equation. So this part's easy. Figuring out the numbers that go here and here come from our balanced equation. Look for the coefficient, the number of moles next to that piece. Because remember, guys, this is in our last video, this is our mole ratio right here. Notice that's what it says in orange right here. So we get our mole ratio numbers from our balanced equation. Okay? So, moles of aluminum. Oh, take a look. There were 4 moles of aluminum, and I had 2 moles of aluminum oxide. So now, let's see. Do my units cancel out? Yes. Aluminum oxide is gone. I am left here with just aluminum. That's what I want in the end. How many moles of aluminum will be in the end? So, moles of aluminum will be my final unit. Now all I have to do is just do the math. This is where you can simplify. Yet in the last video I said, hey, when you're asked to write a mole ratio, don't simplify. But now that we have to do the math, if you want to simplify, you can. If you don't, just multiply all your tops together, get a new top, multiply all your bottoms together, get a new bottom, then do your division. Or if you go top times top, divide by bottom, or however many you have, you'll get to the same answer. Don't let the calculator be your issue here. Okay? Practice this, practice this, practice this. I'm going to simplify. 4 divided by 2 is just going to be 2. 13 times 2, 26 moles of aluminum is what I would have. Okay? So, is this anything completely brand new? We've done these T-charts, guys, so many times before. It's just a new application of where we get the numbers from. So, my encouragement to you guys right now is to pause the video, try this problem on your own. If you get stuck, play the video and pick up where you get stuck, or try it and go back and redo it. The best way to practice this, guys, is to just jump right in, okay? All right, so let's go over this problem here. First thing you have to do is you have to balance this equation, and I'll be honest, this was a challenging one to balance. When you go through it, you might think, okay, well, 2 here, 1 there, 3 here, but then when you get to this point, guys, notice, remember, 3 distributes to both of those, so everything else is balancing up oxygen. This was a trick I tried to show a lot of people. Notice how we have an odd number here. Well, we can't have just a half a number. We have to have whole number moles within our equation to balance it out. So if I have 3 here, that means this would really be 1.5. I can't have that. So what I can do is let's just go through and multiply all of these numbers by 2. Okay, so what you should end up with if you balance this correctly would be 4, 3, 2, 6. And that is the lowest number whole ratio, because if you think, well, I can just divide everything by 2. You can't divide 3 by 2. It won't be a whole number. So this is what you should have for your balanced equation. Now, once you know you have a balanced equation, you can jump right in. So let's go through and start doing this. How many moles of water? Okay, so I'm just going to kind of box this to get myself set up. So my given, I always write this down first. I am given 20 moles of ammonia. And if you don't remember ammonia, guys, if you look in your reference packet on the common table of bases, I think it's like K or L, ammonia is one of those. It's NH3. Now, if you go by process of elimination, you should know that, hey, O2 is oxygen, N2 is nitrogen, H2O, that's water. So what's the only one left over? Oh yeah, NH3 is going to be ammonia. So my wanted, and I'm going to stop using colors toward the end of this unit here, but for now I want to kind of show you guys where I'm getting this stuff. I'm trying to get to moles of water. Okay, so mole to mole problem, it's going to be one step. I'm following my roadmap, which I have up here. Again, this roadmap is not going to stay this simple. It will get bigger, but again, by writing down your given and your wanted, it's going to help you kind of identify that. So I'm starting with 20 moles of NH3. One step problem going from substance to substance. So moles of NH3 will be on the bottom, and then my moles of my wanted will go on the top. In this case, it's water. So now I've got my units set up. I know that, hey, I'm in the right, I've set it up correctly because moles of NH3 and moles of NH3 have canceled out. So all I have left to do are figure out my numbers. Where do I get the numbers from for my moles of each? Oh yeah, I go to my balanced equation. So water, I had 6 moles of water, and I had 4 moles of ammonia. So now I can go through and do the math because I know that, hey, this is what I want to get to in the end is moles of H2O. So I can do some simplifying here. I can divide both of these by 2. Oops. I can say this is going to be 3, this is going to be 2. I can do some more simplifying if I want to. I can divide 2 and 20. So really, it's just 10 times 3. You should end up with 30 moles of H2O. Guys, if you were confused on how I just reduced that, you don't need to reduce it if you're not comfortable. Just use your calculator. But you can also reduce it if you're more comfortable with that. So what you guys are going to work on now is page 6, which is using mole ratios like we learned, and then doing some mole-to-mole problems. So until next time, enjoy your practice.